So I select that. There's probably a better way to do this now. I think I might have it written down, but we can do it this way. So we are choosing numbers. You know what? If I'm going to use this, then I shouldn't have done 0, 0 to 59 if I'm going to use the calculator. I should have, well, yeah, I think we're not going to use the calculator for this. I think I still use table D because 0, 0, I don't know that 0, 0 is going to come up, but I'm not even sure how to write that in there. So let's go back to table D and we'll write down those 2-digit numbers. We'll start with line of 101. That's usually what we do. So we have 19, 22, 39. 19, 22, 39. Now when it's written on a piece of paper, you can write right on the top of it, but I can't write on the top of that. But on a quiz, you can. Okay, so I have 19, 22, 39. So what is this? Senior, senior, senior. So that's a senior, that's a senior, that's a senior. We have to keep going until we get 4 seniors and 2 juniors. So after 39, I get 50, 34, 50, 34, 5. 50, 34, 5. 50 is a senior, senior, senior. Oh boy, we gotta see how many times it's gonna get us. 1, 2, 3, 4, 5, 6. All right, after 0, 5, I get 75, 62. 75, 62. So here's my 1, 2, 3, 4 seniors. I gotta get to 2 juniors. 75, hey, we have a junior. 62, hey, we have a junior. Let's see how many numbers we selected. 1, 2, 3, 4, 5, 6, 7, 8. So it took us 8 times. So if we're seeing what's the probability you must draw 8 or more, we found our first trial is complete. So after 62, now you can't start the next line, you just keep going. Okay, so 62 is there. So I have 87, 13, 96. 87, 13, 96. 40, 91. 40, 91. Let's see, 87 is a junior. This is a senior. This is a junior. This is a senior. This is a junior. 1, 2, 3, 4, 5. We need 3 more after 96. So it looks like I get, oh, that's supposed to be 91. I'm sorry. It's supposed to be 91. It's still a junior. 91. After 91, I get 25, 31, 42. 25, 31, 42. So 25 is a senior, this is a senior, and 42 is a senior. 1, 2, 3, 4, 5, 6, 7, 8. However, 1, 2, 3, 4, I did it in 7. Okay, there's my 2 juniors. 1, 2, 3, 4. So this took me 7 times. Okay, let's do another trial. 42 is my last number over there. So I have 54, 48, 28. 54, 48, 28. 53, and then 73. 53, then 73. So 54 is a senior, 48 is a senior, 28 is a senior, 53 is a senior, 73 is a junior. So I've got my 4 seniors, I need 1 more junior. After 73, I get 67. Look at that, a junior. We got it in the least amount of times, we got it in 6. Okay, so ideally what you would do is you would do this a few more times. So let's do it 2 more times and we'll see what happens. We're only going to do 5 simulations here. So 67 is my last one. Okay, so I have 64, 71, 50. 64, 71, 50. 99, 40, 00. 99, 40, 00. So I have a junior, I have a junior, I have a senior, I have an ignore. Okay, our first, ignore. 40 is a senior. 00 is a senior. 1, 2, 3. I need 1 more senior. All right. After 00, I have 1927. So 19, that's a senior. 1, 2, 3, 4, 5, 6, 7. took 7 numbers. Okay, so right now it looks like let's say we're going to stop. So our conclude, what's the probability we must draw 8 or more names? You can say that you ran 4 trials. Now ideally you're going to run a few more trials, okay, but we're going to say according to our simulation, according to our simulation, we had to draw 8 or more names, 8 or more names 1 out of 4 times. So we are led to believe the probability it must take to draw 8 or more names, the probability to draw 8 or more names is 25%. Something like that. Okay, like I said, ideally you're going to do more simulations or trials, but I think you guys get the idea. All right, moving right along. One last page, one last simulation for you. I got 2 words for you. All right, so let's take a look. Department picnic. This sounds like a riveting time, doesn't it? At a department picnic. 18 students in the math statistics department at a university decide to play a softball game. I know who wrote this question too. It's one of the authors of the book. There's one guy that's kind of a regular guy, and the other guy is a really nice guy, but he's really nerdy. This is probably his idea of fun. So at a department picnic, 18 students in the math science department at our university decided to play a softball game. 12 of the 18 are math majors and 6 are stats majors. To divide into 2 teams of 9, one of the professors puts all the players' names into a hat and drew out 9 players to form one team, with the remaining 9 players forming the other team. The players were surprised when one team was made up entirely of math majors. Is it possible that the names weren't adequately mixed in the hat, or could this have happened by chance? Design and carry out a simulation. Well, here we are with another simulation, okay? So let's do our state plan, do and conclude. State plan, do, conclude. All right. Is it possible or could, let's see, is it possible the names were adequately mixed? So how likely is it for a team to be made up entirely of math majors? All right, so let's take a look. So for math majors, ready? We are going to let them be, how many math majors are there? There's 18 total students, and there's 12. So I'm going to say 0, 1 to 12 are going to stand for the math majors, and the stats majors are going to be 13 to what? 18? 13 to 18 will be the stats majors, and then we are going to ignore the numbers 19 through 99 and 00. Okay, so we'll do this one with a calculator. So we need to select 9 unique, which means no repeats, 9 unique 2-digit numbers. That's what we're going to do. We're going to select 9 unique 2-digit numbers. That's going to represent one of our trials. And then we're going to count how many math majors in the trial, okay? And then we'll perform, I don't know, say we'll do 5 trials. Maybe we'll do more. okay? And then we'll find the percent that are all maths, all nerds, all math nerds. All right, I'm one of them. I'm one of them, guys. Some of you guys are too. Who's kidding who? Vinny be the king of the stats line, wouldn't he? He's a good stats guy. He's a real good stats dude. All right, so let's take a look. Let's use a calculator. So this is what we're gonna do. We are going to random integer, okay? Random integer. So let me show you how I got there again. I hit math. I went down to PRB for probability, and I went down to random integer, okay? And now I want to pick numbers from 1 to 18. Those are the numbers that I'm looking for. So I put 1, comma, 18. And then after that, I could put a comma and put, what can I pick? Ignore, we said ignore 19 to 99. And then we also here have to ignore repeats. Okay, even though I said here unique, I think it's good to say ignoring repeats there too. So how many do we want to pick at a time? You could say 9, but sometimes you're going to get some repeats in there. Okay, so let's just do, just for now, let's do 10 at a time. Okay, so let's look. So they've got, these are the numbers, the first trial. 3, 10, 8, 14, 1, 7. No repeats yet, right? 1, 7, 18, 4, 18, 4, 15. Let's look. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I think those numbers are unique. So let's look. So we got a math major, we got a math major, we got a math major, we got a stats major. So right away, I know that this trial failed in terms of being all math majors. So I can stop. Okay, let's do that again. If I hit enter, it should do it again. Okay, 4, 7, 1, 17, 4, 7, 1, 17, 2. Now 1 came up again. I can't count that. Okay, I can't count that second 1 because we had to ignore repeats. So then I go to 10, and after 10, 16 comes up. 1, 2, 3, 4, 5, 6, 7. I need 2 more. 18 and 6. 18 and 6. Make sure there's no repeats. There's repeats. Yell at me. You guys got to stop me, all right? So 4, we get 1 to 12. So that's going to be math. That's going to be math. That's going to be math. Oh, we get a stats 1. The trial fails. So let's do it again. 5, 3, 1, 14. 5, 3, 1, 14. 1. I can't use it again. 8, 6. Now, somewhere in here, remember we talked about using table D? We are going to say we're using a random number generator to select the 2-digit numbers. I guess it doesn't matter. To select the numbers. 2 digits doesn't matter for this. The 2-digit stuff matters when we're doing a table D. So 5, 3, 1, 14, 8, 6. 18, 16. 1, 2, 3, 4, 5, 6, 7, 8. I gotta do it again. So this next one, the first number, 12. Okay, so there we go. So let's look. Ready? Math, math, math. Uh-oh, here we go. Here's our chance. Stats. Okay, so you would run it a few times, and then you'd look and see how many times you got the all math majors. So far, we'd say, in my simulations, I didn't come up with any teams that were filled up of entirely math majors. Therefore, I don't think it's likely for a team to be made up of entirely of math majors. Okay? According to my simulation, 0% of this happened. So you just think it's not likely. I wouldn't say this could happen, this can't happen, it's going to happen 0% of the time. You don't want to say that. All right? There's 5-1, guys. Hope it makes sense. Hope this stuff resonates with you. Okay? Got it.